Have you ever wondered how you could do some image understanding with Amazon Nova Lite in Python? If so, please check out this GitHub repo, Amazon Bedrock samples. QR code over there, link in the description. Once you've cloned that repo, go and navigate into Multimodal Nova and then open the Jupyter Notebook Nova Lite Multimodal example. Let's take a look. Over here, in my friendly neighborhood IDE, I have that repo cloned. I've gone on down to multimodal and then Nova, and inside there we have this notebook. So I've opened the notebook here, and then I also went and noticed that there is a images folder here, and I went and opened up one of those images over on the right hand side. Looks like penguins to me. So let's take a look. I'm going to close off that panel right there. I'm going to go here, close off the panel on the right as well for now, and let's forge ahead into here. The context, doing image understanding using Amazon Nova Lite. Certainly Amazon Nova Pro is a capable model that you could use to do image and video understanding as well. But this demonstration uses Amazon Nova Lite. The example here indicates that the version of the repo I just cloned, that they're going to use invoke model, but that I think they changed. I'll show you more about that down below. Down here, make sure you set up some dependencies. Here, you might also want to do, besides this pip install of Bodo 3 and Bodo Core, you also want to make sure that you do a pip install of Pillow so that you have the Python imaging library. Here they restart the kernel, and then we get to the Python code. So importing Bodo 3, JSON, base64, and then image from the pill. Then Bedrock client right here, they notice they want to use Bedrock runtime because they're invoking a model with the Converse API or the invoke model API. Either way, they're both on that Bedrock runtime, not the Bedrock service specifically there. And then here there's a region that the Amazon Nova Lite model is available in. Make sure you choose an appropriate region for your needs based on where you're operating and where the models are available. All right, let's get to it. So here they built some helper functions. Let me show you the second one first. So down here, notice that they use the Bedrock client Converse API. The distinction between the Converse API and the invoke model is shown over in the documentation, in the user guide for Amazon Nova. Here, I'm just going to search for Python and scrolling down, and note that this example here, pretty fundamental, goes over setting up Bodo 3 and JSON in here in this case, and then getting client reference to, again, Bedrock runtime here, saving that away, and then taking that and on there, going and doing Converse with the model, Amazon Nova Lite, this particular version. The messages that are sent in are assembled up here in this code, the role of user and the content with the text, write a short poem. But we want to do image understanding. So we don't want to just give text in here. I want to give something more. And then they process the response. Over here in the documentation, you can check out using either the Converse API or the invoke API. Great documentation there. But I'm going to go down one document to the complete request schema. In here, they indicate the system prompt that you could give, and we'll have an example of that in the code. And then messages. In the messages section, notice the role here is the user is established, and then the content. Now the content could be video, as indicated down here, and the other alternatives are image and text. Now here's an interesting distinction between the invoke model and Converse APIs in Amazon Bedrock. Notice that for an image, it indicates that that would be a binary array in the case of the Converse API, yet a base64 encoded string for the invoke model API. All right, so again, choose whichever of those models of excuse me, whichever one of those APIs best meets your needs, invoke or converse, choose the model also that best meets your needs. If you want to do image understanding and have that image and video capability again, we would want to be using Amazon Nova Lite or potentially Amazon Nova Pro. Once again, this demonstration goes and uses the model here, Amazon Nova Lite, specified there. Two functions here. One of them takes then an image path, ignores the message prompt here actually. I'll show you where that's done later. Then this will go, and because they're going to use the Converse model later, this doesn't actually use this base 64 encoded value. That's never referenced down here. Instead, they take the image bytes, the raw binary stuff that accumulated when they opened up the image file at the image path right here. So really, we just need that first parameter in this particular version of this. This is also going to take the format off of this image path and determine is it a JPEG or PNG or what kind of file is that. So it's really just going to build up this image with format and source that again are specified back in the documentation that we want right here. Those two ingredients in the image piece. But wait, what about a text prompt as well to describe what we want to have Amazon Nova Lite do with that image or those images, if there's more than one of them? Well, that is done in this particular code in a different place. This function, read and encode image, is used in another function down below. So let me actually run that helper function. There we go. Okay, so that ran. So now that's defined. There's the next one here is going to use that read and encode image, but then just after they get this value, this message content back, and append that to our content list, what they're going to do is they're going to then take the message prompt, which is passed in from along with that image, and it's going to then append that also, separate text elements. So we're going to have inevitably both the image element and the text element together appended to the content list. It's just that this code was refactored a little bit when they decided to switch over to the Converse API, and I think they just kind of left that parameter passed in there, even though it's ignored in the earlier definition. That's fine. It's flexible. You could switch back to the invoke API, switch back to different ways this list would be encoded. The system message is going to take the system prompt that was passed in also to this function here, and then they're going to take that, add in the content list of text and, or I should say, image and text pairs. If you have 1, 2, 3, 4, 5 images, you'll get the image and text, and so on. And then the role also at top level there in the messages. They then have here some old vestigial code of inference parameters. There you could change the maximum tokens here to some other value, the temperature to some other value. But in this case, they don't really use those. They just have this kind of reference like, oh, we could have used those here. And then down below, they go ahead and then get all those pieces together, and then go here and then return the result. So a few usage examples here describing an image. They have this animal definition here, and then they go and indicate you're a wildlife explorer, use the image and provide a hilarious response for what is in this image and that particular path there. Again, using the Converse API, that function described earlier. Let's take a look. So I'm going to define that first function there, and then come down here and run this, and the response we get back. Image shows 3 penguins standing on a beach, probably posing for a photo. They're standing in a row, facing the same direction, and so on. So there's some response back here of what those penguins are doing. All right. Next, this scenario is to do a vehicle damage assessment. So we're going to pass 2 images. A image of a car, image before an accident, and then one after an accident. Let's take a look. Here's an image, presumably before the accident, and maybe when the client got insurance coverage. And then here is one where it looks like the bumper has had some kind of incident occur. All right. So in here in the Python code, we just use that pillow to go and grab both of those, display them. None of that in the video. It's on another display. That's why I showed them to you ahead of time. Here's the prompt, system prompt in here. In this case, a little bit longer. It goes through some details of what is expected in here. And then the image list, again, has those two ingredients, both the image path, which is going to be transformed into the contents of that image, and then the message prompt, which is going to be transformed into the text element. So we're going to get image and text elements for that, and then image and text elements for the after effect and the after image. And then send the system prompt and that list of images there into this response model. And whoops, hang on. Let me go run that. And then this gives an assessment of the insurance situation, the damage situation as well. Structured data extraction. Here we have an e-commerce catalog manager, and we want to take an image of a product. Let me show you an example over here. We have a piece of luggage. There. We could go in and assess some details about it. So let's say that we have some different categories we would want to analyze in our product catalog. But specifically, we want to ensure that the output is in a certain JSON schema. And we have some particular details about populating fields accurately based on the image. And then if there is not a particular value that's known, determinable by the model, then unknown will be provided or an empty array. So very specific details here, specific schema, including category, metadata with color, shape, condition, material, and brand, and then some image quality, background, additional features like type and items. So here, then they take that luggage item and then send it on down into the Converse model for Amazon Nova Lite to assess. Here, let's take a look. There we go. And so carry-on luggage, and then gray carry-on suitcase with wheels and handle. It is rectangular in shape. Color is gray, and so on. So it has followed the model has followed the output schema that we wanted. But again, input is based on the image, so analysis of the image. So let's take a look at another example using the same kind of use case. Product manager wants to build their catalog. They have a dresser. So let's take a look at the dresser image over here, and there has some items on top, has a number of drawers there, and a certain color and setting there of that image. So over here, they just run the same code, and they say this is the product picture, that's the product path, and then invoke using the Converse API here. And the response that we get back for this one, then gray office storage cabinet and multiple drawers, a top shelf, placed in a room with a bulletin board and so on. And so it describes also the scene and then some features here of that. So it follows the JSON output schema. And again, as the functions that we're using, we're going to indicate the output of also the usage, the input tokens, output tokens, and total token counts that Amazon Bedrock is going to bill for with the on-demand pricing for the Amazon Nova Understanding models. Let's look at another example here, chart analysis. There's quite a lot of detail in the prompt here. This is going to ask for an analysis of the kind of chart that is here and then what the content really is like. So let me just hit run for that. But I'm going to go also over here and just pop up an image of that over here and zoom in on that. So this has the net sales and operating income bar chart here with quarterly reporting for 5 quarters here. And then the y-axis here has the price of net sales in the millions of dollars units, and then the operating income also in millions of dollars here, and the quarterly breakdown there of these bar graphs. There is a year-on-year assessment. Things are going up, which is good for the business, hopefully. And then here also the other values summarized at the bottom. So this is all in an image, though. This is in a graphic that someone had generated. So could we use this model to go and assess what this can be described as? So down here, goes through bar chart showing response for North America, goes through summarization of that information, and then details on that information, and then net sales and so on there. So once again, this has been a demonstration of how to use Amazon Nova Lite within Amazon Bedrock using the Converse API in Python. So check out that Jupyter notebook. Once again, just do a git clone, go in to the notebook there, and then can go through and check out whichever of those examples or all of them you might want to investigate further. Thanks and good luck. Oh, one more thing. So if you want to learn more about Amazon Nova models, there's a course on AWS Skill Builder titled Exploring Amazon Nova Models Using Amazon Bedrock. Hit the QR code here or the link in the description. In there are some videos and knowledge checks you could go through. It's a kind of fundamental starting point. It does not have examples in Python, but examples in the playgrounds in the AWS console, Amazon Bedrock. Call to action is, if you do want to check out that course, please enroll and then go through the course at your own pace. Go back and review it whenever you like. And there are a few links here also to learn more if you don't want to check out the course, or if you do check out that course, these are also useful references, I hope, for you. Thank you for tuning in for this video, and let me know what you'd like me to demonstrate, draw, or sing about perhaps in the future. Until next time, take care.